So good morning. Now we are coming on next topic on function, that is composition of functions. Now what is composition means? We are combining two functions together. Addition we have done, multiplication we have done, division we have done, difference we have done. Now we are coming on composition of the function. In that case, if we have one function f from a to b, this is first function we have. Another function we have g from b to c. This is the second function we have. One function is a to b, another function we have b to c. And now we want the composition of these two functions. First, if I take function f, this is our function f going from a to b. And from b to c, another function is going, that will be the function g. Here we have the element x. Its image, if I take, that will come out to be fx under the function fx, and this will take as y. And this y will have under the function g image this side as g of y. Then what we are finding here, x which you have taken element from here now have the image in c. Through b, x is an element which will give image here, and this image will further have the image here. So that means each and every element in this set will have the image here, because this is a function, this is a function. So each and every element here has the image, and then each element has the image here. So that means now we have a new function defined that is going from a to c. And this function we call as, now just check here one more thing here, g, y can be written as fx. So this function which will go from here to here is called g composition f. G composition f means first function is f, and on that we have imposed g. This is function f, on that we have imposed another function g. It is called g composition f. So there is another function now we have defined, that is called composition of GOF. First function is f, on that we have imposed g. So g composition f is the composition of two functions, and this function will go from a to c. So GOF going from a to c. This is the function we have. And keep in mind now g composition fx, as this function is GOF, it is x here, and its image will be here, we call as g composition fx. And this is equal to what? This result is same as this, g of fx. For all x belongs to a. This is called composition of function. So if f is a function going from a to b, g is another function going from b to c, then from a to c via b we got a function now which is called as g composition f, and in this case g composition fx will be defined as g of fx for all x belongs to a. So this is the composition of function we have. This is the composition of g and f here. After this now, by the way, if I say in this case, I'll take the reverse way. Reverse way means if I just say, I'll take this time g function first and f function second. If you take g function here, that will go from b to c. This is our function g. And then another function is going from a to b. First function this time in the second part, what I am doing here, first function I have taken g and another is f. Now in this case there is a problem that c and a we don't have any information. So we'll get the function from here to here directly or not, just check here. If X is an element here, then its image come out to be Gx, which is taken as Y. And if this Y is here, if this Y is present here, then you can have a further image f of y, or I should say fg of x. But if y is not here, we will say this function cannot exist. So that means what you want in this case, if you want this function to exist, all y which are in C, y means which are in C, which are behaving as image of x, must be here. Then we can say, yes, I can have the function going from this to this. And this function will be now called as f composition g. This is the element x we have. So we will say f composition gx will be f of gx for all x belongs to, this time it is b. And in this case, f composite g function you take, that will be going from B to B. But here in this case, one thing we should keep in mind, whatever the element which are behaving as image must be present here. That means what condition must be there? Range of this. Range means the collection of images. That must be present in A. So this is only possible when what I should say, range of G. Range of G is a subset of domain of F. So if this condition hold, that is range of G is a subset of domain of F, I will say yes, this function will exist. In this case, the problem was not there because this was the common element. But here in this case, when you think about F composite G, range of G must be domain of F. Subset of domain of F means all the range element must be here. Then we will say yes, FOG will be going to exist. And from where to where FOG will go? It will go from B to B. And how it will define FOGX is F of GX for all X belongs to. So this is the composition of the function. And now one more thing note here. When you have composition of FOG, one function we have done GOF that will go from A to C. And another function is F composite G that will go from B to B. These functions are having domain different, they are codomain different. That means these two functions in general not equal. So one property you should keep in mind now. GOF is not equal to FOG in general. GOF is not equal to FOG in general. In general, this condition does not hold. So you can't say that FOG and GOF are coming equal. In few cases, it can be equal. In few cases means if it go from real to real, this is also going from real to real. We'll say yes, it will be possible. So that means we will say this will be the composition. Now how we are going to get the composition of function when two functions are given, how to solve it, I'll just show that. This is the question we have. F is the function going from real to real, fx is x square. G is going from real to real, gx is 2x plus 1. My question is find out what is G composition F and F composition G. These are the two questions they are asking. When we want G composition F, first thing is clear, F function to be taken. F function if you want, that means it will be going from real to real and this is F. Then second function will be G. That is also going from R to R. And here we have the element X. The image of this will be Fx first, which will become Y. And then its further image G of Fx. And this function will be G composition F. So here one thing is clear, whenever they are asking G composition F, what it will be? It will be going from real to real. Here if you have the element x, what will be your fx? Fx comes out to be x square. Just check here. And this x square, what it will come? G of x square now. And g of x square. G of here x square means it come out to be 2x square plus 1. We can solve this way or you do this way. G of fx, then the result says G of fx is G of fx for all x belongs to real. Now have we solved it? Just check here. G, what is fx? Fx is this time x square. And then G of x square. X square means here it comes out to be x square. What it will come out to be? 2 times x square plus 1. So I got it. G of fx is 2x square plus 1 going from R to R. This is the first result we have. Now when you want FOG, in that case this function will be G this time. First will be G, then second will be F. Then what change will be here? X, and this will come Gx. This will come F of Gx. And this function will be now F composition G. And now when you solve it, F composition G will be going again from R to R. And now I want F composition Gx will be F of Gx. Now what is your Gx is 2x plus 1. So it come out to be F of 2x plus 1. Now what is fx is x square? Fx is x square means what it will come? 2x plus 1 whole square. Now just check. GOF and FOG both are going from R to R means their domain are same, their codomain are same. But what you will find, GOFX is coming 2x square plus 1 and 2x plus 1 whole square is here. So we will say GOF is not equal to FOG. This is the question. So one question, you can calculate GOF also, FOG also. Another example we have, function is going from real number to real number, fx is sin x. G is again going from R to R and it is Gx is x square. My question is, find out FOG and GOF now. FOG and GOF. When you think about FOG, again we will say first function will be G going from R to R. This is function G and then this will be your function F, R to R. Here we have the element X, so image come out to be Gx first and then it come out to be F of Gx. So we are calculating first is FOG. So FOG will go from where to where? It will go from R to R. And now every time this is not needed that you will make the diagram. Directly also you should remember. FOG whenever I take, we should take domain of first function. What is the first function? G is the first function here. So what is the domain of that? It's all the real number here. Then whatever second function, its codomain I'll take. Second function is F. It is again real number. So it will go from real to real. Whatever first function's domain and whatever the second function codomain, from there to there the function will go. FOG R to R. And now when you solve it, FOGX will come out to be what? F of Gx. And what is F of Gx means? It is x square. X square here. And F of x square when I take x square here, so it will come out to be sine of x square. Same way when you think about GOF, what is the first function? F. F is the first function, so domain is R. G is the second function, so domain is again R. And then we go for G composition Fx will be what? g of fx. And fx is what this time? Sin x. So we'll write this will be g sine of x. And now gx, what is x here? Sin x, and it is squared, so it will come out to be sine x whole square. So we will say again they are not equal, their domain are same, their codomain are same, but the values of the function are not coming same. So we will say again FOG is not equal to GUF. That also you should remember. So anyway, now you can try FOG you calculate and GUF you can calculate. Next video will go.